Now the million-dollar question is, can we infer causal theory from a correlation? Let's take a look at some correlation examples to see why that could or could not be the case. So these are correlations from actual observed data. We can see that the correlation between US spending on science, space and technology is correlated almost perfectly with suicides by hanging, strangulation and suffocation for a 10-year period. Can we make a claim that if US increases spending, then suicides and hanging will increase? Or can we say that US should decrease science spending so that less people will make suicides? That's an implausible claim, so that's unlikely to be true. And the reason why there's a correlation is that there could be a common cause. For example, it could be that the population is growing, and when there is more population, there is more tax dollars, there is more spending because there's more tax dollars, and also because there's more people, there's more suicides. Or this could be because of the state of the economy. Let's say that the economy is growing and both of these are growing as the economy grows, or so forth. Or it could be just by chance only. 10 observations, 10 years is not that much. So if you have large data sets and you keep on data mining those data sets, like this Tyler Wiggins who made these graphs did, you will find some large correlations. For example, number of people who drowned by falling into a pool and films where Nicolas Cage was the star also correlated. So claiming causality from this correlation would be ridiculous. So can we ever make a claim based on a correlation? To understand, we have to understand what is the hypothetico-deductive method in science. The hypothetico-deductive method differentiates between two contexts. First, we have the context of discovery, how we come up with new theories, and the context of discovery is how we generate theoretical hypotheses. So in hypothetical-deductive method, the starting point is a hypothesis. It's a guess of what the result could be. So it's a guess that maybe the US spending on space and science actually causes deaths by suffocation and hanging. So it's simply a guess, and it doesn't really matter how we come up with the guess. Then we have the context of justification. So how do we justify this claim that US spending on space and science actually increases deaths by suffocation and hanging? In hypothetico-deductive reasoning or research logic, we apply deductive reasoning. So we assume that the hypothesis is true. Then we assume some other auxiliary hypothesis, and we then deduce what things we should observe if this main hypothesis and the auxiliary hypothesis are true. Then these observable consequences in a research paper are typically presented as statistical hypotheses. So whereas hypothetico-deductive reasoning or the logic of hypothetico-deductive research doesn't really say that the observable consequences must be presented as statistical hypotheses, that is how it's commonly done. So one a bit confusing thing here is that the hypothetico-deductive method, the hypothesis is the theoretical claim. So that's a hypothesis, we think it could be correct. But in practice, when we apply hypothetico-deductive reasoning, we use the term hypothesis for the observable consequence. And that can cause some problem, some confusion. So we have a hypothesis that we should observe if the theory is correct, and if some auxiliary hypotheses that we'll cover later are correct as well, then we can test with data. So if our statistical hypothesis is not supported, we don't observe the predicted observation, then we infer that the theory or the actual initial hypothesis must have been incorrect. It's of course possible also that the auxiliary hypothesis, one of them, is not correct. We don't know. That is, that we don't know which of the hypotheses is incorrect is referred to as underdetermination problem of science. But that's how we do. So we don't observe something, we infer that the theory is probably incorrect. On the other hand, if we observe the deduced consequence of the theory, then we can claim that the theoretical proposition could be correct. We can't claim that it's definitely correct because deduction doesn't work that way. We can only refute theories, we can't support theories using deductive reasoning. The way the support for a theory comes is when it has been tested over and over and it has survived many severe tests. Then we can say that if this theory can't be challenged, then it's probably true. So how it relates to the previous figure. So we have induction and we have deduction. We can actually apply inductive reasoning, but only for the context of discovery. So we can make theoretical claims based on correlation. We can see that there's a correlation with the US spending on science and technology, and then deaths by suicides and hanging. But we can't use the correlation that we used to make a initial guess or initial hypothesis. We can't use that to justify the claim. So of course, where the initial theory comes from, it doesn't matter. What matters is whether we can justify the theory empirically. And inductive reasoning cannot really be used in the context of justification in quantitative research. It would be very unlikely that your observed correlation that you happen to observe actually fills the requirements that we need for making causal claims without it being a result from a research design that was specifically designed to do that. So in deduction, deductive logic can be used to justify claims, and inductive logic can be used to come up with the claims. But of course, when you come up with a claim, you also have to come up with the justification. Unless it's a paper where you just present a claim. For example, papers in the academic management review only present claims and no empirical evidence. Of course, in the context of justification, we have to have auxiliary hypotheses that are true as well. So here we would have to have the auxiliary hypothesis that this empirical concept, let's call it return on assets data from the trade register and theoretical concept of performance, we have to have the assumption that this empirical concept is a valid measure of the theoretical concept, and also that this measurement result here is reliable measure of this empirical concept, and that there are no other causes that cause this statistical association. So we have to have these many different auxiliary hypotheses. If we don't observe something, it could be that the initial proposition is incorrect, or it could be that the auxiliary hypothesis is incorrect. We don't know which one it is. We conveniently assume that it's always the proposition, but that's not always the case. So finally, you can make claims based on statistics, on correlation. So you can make a causal claim based on a correlation, but you cannot justify a causal claim only by a correlation. So sometimes you find interesting correlations in your data, then you start to think why there's a correlation, you come up with a theory. That's completely okay as long as you don't present that correlation that made you come up with the theory as an evidence for the justification of the theory. So you have to keep the context of discovery and the context of justification separately.